Swayam Prabha. Digital India. Educated India.
Welcome. We are in the discussion of mineral processing plant equipment, particularly for handling the bulk material in a mineral processing plant. We require different type of operations, processing operations, out of which this concentrating is one of the major operation, that in which that we need to separate the gangue material, so that in the mineral we are having higher concentrations of the valuables. So, for that there are various methods and various techniques. So, we have introduced earlier in our discussions certain nomenclature you have heard about, called Froth flotation, magnetic separation, jigging, this thickening, all these applications are there. So, after this class you will be able to explain the principles and the applications of these processes. The Froth flotation is one of the oldest technique, and it is being used in the processing plants of various type of ore, particularly wherever we are having the sulfide ores, or even in some of the other minerals also, but there are whether to separate out in the froth the mineral, or we are separating out the gangue material. So, this process basically it involves, that is you introduce air bubbles. As you can see here, there are air bubbles, and then the mixture, when you put it this mixture over here, that when the air going at a high velocity and with a stirrer we are stirring it out, in that the bubble formation is there, and these bubbles there we give this all your tertiary grind material after the ball mill or autogenous mill, our the ground minerals that with ore, that rock forming materials, all these things together they are introduced over there, and then you add some other reagents and oils. So, what happens there? There is a difference in the weightability, that is how these particles, finely divided particles, how they get weighted, there is a difference. Some particles they are exactly weighted by oil, some particles are weighted by this or weighted means moistened. Say for example, if your certain particles, the sulfides particularly, if there is oil, it has got more affinity to that and they get exactly weight by oil, but some things they do not get weight by oil, but they get weight by water. So, these differences of property that is used in separating them out. So, this depending on how they get attracted to that oil, and then they get picked up by these bubbles, and then as you know that because of the buoyancy, bubbles have got that your inside is free volume is more, so that they get come up to the top. So, they in that environment of agitations and air, these bubbles they makes this foam or the froths, and that froth you take it out. As you can see here, that is your, we are having the agitator, and then we are getting this air, and there they makes this bubbles formation. This feed containing ore in a form of slurry, that say when they are coming over here, they make the major things with that bubble. Now, this your ore particles, surface particles with the oil and all, they will get attracted to the bubbles and they will be collected over here, and then those gangue material they will be taken out through this as an underflow. So, this is how, but we have this flotation system as two type, that is direct flotation or reverse flotation. In the direct flotation, your mineral particles, they float with the bubbles. So, this is what is happening, mainly the anionic reagents such as your petroleum, sulfonates or fatty acids, when they are put it over there, they will attract those things and it will be going. And then normally what is happen, if you are using cationic reagents, then this organic depressions such as stars or synthetic organic polymers, they are used with this, and then the waste rock, they will be going along with this float, and that is called your reverse flotations. So, in the whole process of Froth flotations, there are different types of the systems are exactly you can design depending on the plant size, depending on where it will have to be accommodated, what is their location in the other with the other processing lines, then the design will be done in the plant design. But basically as a component wise, how it will be there, you can think of with this diagram, that is your, if we are doing this mainly for the hydrophobicity or this oilophilicity, this depending on that, this your lead sulphide or iron sulphide, that pyrite or galena, they are exactly having a, they get moistened by oil, and that gangue material moistened by water. This thing is considered, and that how they put the things in one chamber, when the whole mixture of the feed, they are coming over there, both hydrophobic and hydrophilic materials are entering into this, and then when the bubble is being formed, at that time this adjusts on the how into the bubble, this hydrophobic material, they will get attracted, that is your oily substances, they will get attracted over here, and then they will be coming as a Froth at the top, and they will be taken out. So, like that you have to have. Now, this system in the plant, how will you make the chamber, where from it will be coming, what type of what will be the size of those chambers, these are things done in the bulk that mineral processing plant design. Now, you can see that in a real life, if you see the how the Froth is coming, that is from there, this is flowing over this, they collect the Froth, taste it, whether the things, the required reagents and all are given properly or not. There could be number of chambers the Froth is getting formed. Now, this the efficiency of the system, performance, how it is performing, whether your any valuable minerals all are coming into this Froth or not, that will be depending on number of operating parameters. In a plant design, the handling people, they will be doing mostly the chemical engineers, they metallurgists, they will be finding out, taking the sample, taste it over there, then they will be giving that mechanical engineers, they will be making the control over the systems over there, the electrical engineers, they will be maintaining the control of the how the agitators will be rotating, what will be that motor control will be there, whether you are doing with a frequency control, voltage control, or how you are doing that thing which are remotely from one centralized point, whether your both these systems, that how the Froth is forming and how the operating parameters are changing, whether they can be integrated, and from the one control panel everything will be operating. Those are the things where even the existing plants, they need to continuously keep on studying over there. If the system deteriorates, how it can be improved. So, that is where this area is important. Then I have given you this link in YouTube, you can see the a video to get a better picture of how these things in real life occurs. Now, what is there in this Froth flotation system? Basically, there will be this frothers. Frothers is how the Froth will get formed. That means, the bubbles will have to get formed, and the bubble will have to come up to the surface, and while the bubble come, bubble should not collapse or that should not burst, and then this again the mineral particle should not go to the liquid. There will be certain bubbles will be always collapsing, and then they will be re-picking up and things like that. So, these frothers, they are exactly used to produce small persistent air bubbles, so that the bubbles do not collapse, and it produces a stable and mobile froth, so that the targeted hydrophobic particles can be picked up and they are floated to the top of the things. That is whatever we have said, that is the basic principle of taking the mineral out of this, separating the gangue mineral, and it will that froth will have to be formed and they will have to keep on flowing. While flowing over there, they will be bubble to bubble interactions will be there, and then all the time new bubbles are coming over there. At that time, to maintain that mobility and maintain this without collapsing, you will have to add some materials which is always called that is your the frothers. So, that is the frothers help to recover the area of minerals, because sometimes what happens, the same mineral they may have a different elements, that each of these elements, if it is to be separated, that is also can be controlled with a properly, that mineral processing engineering does that one. But you know that this basic type of frothers that are used, alcohol, glycol, ethers, terpenes, like that, that your organic oils are used, and sometimes you will find that pine oil and all are also used there. The selections of this oil, that will depend on that what type of ore you are using. You need to get only one type of elements will have to be separated, or different type of oil will have different type of elements are there. And then what is the grinding level, that is what is the size range, size distribution, that is whether you are having say 150 micron above, or you are having a 50 to 70 micron and above particles are coming over there, or we are having in some very fine even a 0.01 millimeter size, whatever is coming. Depending on that, you will have to see and select this process. Then what is the percentage of solids are coming in that pulp, that is your slurry, when it is coming, what is the concentration of it, because that the slurry density, it is a matter of all differences are taking place because of the density differences over there. In the pulp, what type of it, that will exactly having a big say over here. Then the how will you treat the pulp or that slurry, and then after introducing the oil, how it will behave, those things separately in your laboratory it is studied. So, that is why in any this type of handling of material, a laboratory study of the properties and the characteristics and their behavior, it is very, very important. Now, there are different type of this frothers have been used. There are many companies, they produce and they give it over there, but now some of the this where they get used, particularly in coal, copper, your gold, lead, even in molybdenum, that is nickel, potash and zinc, these type of elements, they will be getting attracted to different type of frothers and the different type of environment, which depends on the specific gravity at that particular temperature, and their flash point also affect that, and dynamic surface tensions. You know that this is your millinewton per meter, they have given the values over here. You know this whole phenomena here is of your surface tensions, right? Because the bubble formation, that itself is a phenomena of your surface tension. So, these are to be measured in a laboratory and check it over there. As this company is there, they give different companies are there, Quadra company, they have got different type of frothers in which their water solubility is a property. They see some of them are very water soluble, some are sparingly soluble, and then you can see here the water soluble frothers are used in coal, copper or gold pyrites, that is separation they are using, but the sparingly soluble they can be used in this. So, that is a very basic general selection criteria, but while you are going for a particular case, this is for a particular case only. So, most important thing is the how the flotation will be done, it will have to be determined by laboratory study. Now, the quantity of the oil necessary in any Froth flotation operation depends upon number of factors, that is your what kind of oil is used, the recoverable mineral content of the ore, then the percentage of the solids in the pulp, that is the degree of pulverization. I told already how much the quality of grinding, the treatment to which the pulp is subjected to in the interval between the addition of the oil and flotation. This time, during that time, whatever the dynamics is going over there, that is also very important. The duration of the flotation operation, that means how long the material is there, and that is once you have introduced the slurry over there and then oil and all things have introduced in that media, how long these bubbles will be staying from, it will be going and getting raised and then toward there. This retention time of the floats, at that time there will be interactions with new bubbles will be coming, that duration is also very important. And the mineralogical compositions of the ore, then the method of flotation employed, that is whether you are taking in an inclined way you are taking, or you are just only in a horizontal you are taking it out, all those things are taken care of. That means while you are going to design these things in a real life situations, these factors will have to be taken consideration. Now, the overall, that when you are doing this operation of forming the Froth and then adding oil and things like that, you are controlling, you need to consider different parameters which are related to the ore, their mineralogical character, their fineness of grinding, their method of grinding, depending on the which method you have made it, whether it is a autogenous mill only, whether it is a ball mill, whether it is a rod mill, they will be giving a different characteristics of the material. Then the what type of reagents you have used, then what type of your collectors you have added, then this the water which you are using, that water quality, which is whether it is a that hard water or soft water, whether it has got a higher alkalinity, what is the pH value, they also affect it. And also the apparatus, that what for the your agitation purposes, how you are using, how you have given the stirrer for mixing it, whether there is a all the time rotation or you are giving a pulsating also, all these things will be affecting, and the whole treatment method will have to be taken care of. Now, there are different, that is how will you observe that your things are going okay or not. For that, you will have to measure that your when you keep and observe that how much is the recovery, that means your how the percentage differences are coming in your waste and things, that recovery is a very important thing. Then the grade of concentrate, that is your when you are collecting the material over there, that after the Froth, when you are getting that concentrate, their grade is determined. Then the rate of flotation, that is at what rate, how much quantity is coming per hour. Then this what are their exactly copiousness, their consistency, then the size of the bubbles, these are the things. And then size of the bubbles when they are at the top or when they are at the Froth surface they are coming. And then what is the solid load in the bubbles, that how much exactly it is bringing in the particles, mineral particles, how much it is bringing. And then this is how their exactly appearances of the tailings, whether the tailings whatever going as a reject, there also a lot of Froth is going or not. So these are the things observed, and that will be telling about the performance, whether you are doing it well or not. And that is where exactly is in a Froth flotation, as I was telling you, that they can be arranged in a number of them, and then there will be in a plant at one particular platform, then there should be the proper system that they can keep a check and all. And many times the look of the Froths, that will be telling whether the experienced persons can know if the Froth is coming like that, that is okay, the plant is okay, or that when they will find that there are more that uniform, that is your this ruggedness which is coming over here, that is getting different. And this is an area where you can see that if now with the new data acquisition of the images, from the image itself you can do it, and you can find out, okay, in the system this such a controlling parameter, whether that amount of oil or whether the agitator speed or the your that is the concentration of the slurry coming inside in the flotation cell, if they are to be varied, they can be seen from that where optically you can keep on monitoring, and remotely you can give an indications and you can sense. So, those type of modernization and retrofitting services will be coming in near future, we will see it. So, as a learning activity, you target a skill and competency, what you want to do, whether you want to exactly that handling in the introduction side you want to do some improvement, in the monitoring side you can do some improvement, in the control side do you want to develop say exactly how digitally this whole system will have to be managed and controlled, what type of data and informations will have to be brought in. Those things you can first make yourself that what type of skill and competency you want to have, and then ask yourself that whether will you be able to assess the performance of the flotation cell in a mineral processing plant. Then if not, then you can start studying and searching and developing your own competency. How will you ascertain the optimal use of frothers, activators or the whole system. So, if you can find out this type of question you ask yourself, then it will go. So, then we are switching over to the another system, which is our magnetic separation. This also I told you earlier that the magnetic separator, it is done, we can do it in the wet form or in the dry form when the materials are moving. At that time, if your feed material has got the magnetic property, magnetic susceptibility, magnetic that is it can be attracted by magnet, under that conditions you can use this system. System as such, the principle is very simple, that in the mixture there are certain minerals which has got, they can get attracted to the magnet. So, when they are passing through a conveyor belt, this end pulley can be a magnetic pulley. You can make it a magnetic pulley, we can do it again. You know, in the magnetism you have studied, there are permanent magnet, there are this your temporary magnet. Now, nowadays with the ceramic magnets that can be manufactured with a magnetic property, and then when it is there, the magnetic particles being attracted over here, they will be going over here in this way, and the non-magnetic particle will get as a throw as a projectile, and these two get separated. So, if it is your that is magnetite or any magnetic property is there, then their concentration is increased, your purpose is solved. So, this can be done as schematically you can see over here. The feed material is coming like this when it is going. Now, you are having a cross conveyor is running over here. This conveyor belt has got that magnetic item here. So, when then this is a non-magnetic one, the whole thing, that magnet inside up to here, a strong magnet is kept, so that this material get attracted over here, and then they carried on this plate, and then they will be discharged over here. So, this type of systems can be there. Now, basically what you are doing here, you are taking the advantage of the natural magnetic properties, that is your naturally that certain materials are available with the magnetic property, you take that and then you engineer it for separating it out. Now, this what you separate out those things which are exactly valuable for you, it has got economic value, and then which do not have the economic value, that is the gangue material, you can take it. So, particularly in the iron ores, your like magnetite or that ilmenite, these are iron ore, they can be separated from this rock forming materials of the host rock with a which is considered as a contaminant, and that a gangue material, from there you can separate it. Now, this magnetic separation, it is not only in the mineral processing or where you are handling bulk material as ore, but in other sector also, in the bulk material handling, this comes in a biomass, that where you are having producing these wood pellets, or that crushing the woods, and then their wood processing units. So that to making these powder boards and things like that, there also a lot of conveyor belt, and that crushed wood pulp and wood powders are removed there. If any iron particles or any mainly this magnetic particles are coming, they may go into the next processing, they may create problem. So they are called your tramp metal. Tramp metal means whenever in your system some foreign magnetic particles, metallic particles come in, so you are having a magnetic systems to separate it out. In bulk handling, there are a lot of in particularly in ship loading and unloading, then many time there may be nut bolts where many things may get mixed up, and then if they are going with some of the other consumer materials like it handling grains, minerals, etc. Say sometimes what may happen, you may get importing wheat in the barge. That wheat, when it is getting unloaded and with a conveyor belt you are taking over there. Now in that, if there is some foreign materials like a nut, a bolt, or any iron component, wear, etc. comes in, then it becomes very difficult. So that is can be separated from there. Then pulp and paper, in the paper industry also these things, if your metal particles go over there, it will be destroying the quality of it. In the wood processing and mining, we can use this magnetic separator also in the while main in the mines, that when the conveyor belt is carrying the material and then putting into the crushing plant, before putting the crushing plant, all the tramp material that must be removed, or again we are using in the mineral processing plant, when it is ground, at that time if the magnetic particles, as I was telling it, it is a concentrating purpose is also used. Now what is the basic principle of that magnetic separation? That is the magnetic force, that is your how then the gravity force and the hydrodynamic force, all these forces, they need to be analyzed for seeing that how much exactly the magnetic force will be required to separate that out. That basically this is one of the very common equations you will find, where your this magnetic force, this is exactly related to with a k here is a constant, and then this is your intensity of magnetizations, that is your related to the magnetic susceptibility, and we have got the magnetic intensity H here, and then the gradient, that is your magnetic gradient, and then this is your volume of particles. Now if we are very finely dividing the particles, then what will happen, the volume will increase, and at that time we will be requiring then more magnetic force. Then that magnetic force will have to come from again creation of that magnetic flux. So this is very important there. That means how you will be the magnetic force, how much will be there to take, if you are tramp material, that whether the tramp metal which is going over there, they will be attracted or not. If the gravity force of the tramp material is more than this magnetic force, then the material will not get attracted. So wherever you see over there, then by seeing that what type of metals are being attracted and kept over there, and then after what time, if there are a lot of material have already come, then when you will have to remove that and then put it fresh again. These are the things decided on the basis of calculation of the magnetic force. And then there are different companies, they manufacture this type of devices. Now as a magnetic separators, there we say as a drum magnet, exactly this drum or that your end pulley, that will be considered, that will be made a magnetic thing. So that is that then we are telling it as a magnetic drum separator. They are attracting the ferrous material to a magnet element enclosed within a rotating cylindrical stainless steel drum. So there inside they keep it, and that will be coming as a magnet, and they will attract the magnetic particles. These particles are cleared and with every rotation of the drum and are moved to a separate output. They are exactly the main material when it is coming, where it is discharged, the magnetic one is separated and they give it to the another your discharge panel. Then, so how to get that your optimal recovery, the best recovery you can get, that it will be depending on number of factors. Those basically the type of material being processed, that is in that what type of magnetic particles are there, then how much volume per hour it is carrying, and then what is the particle size. As I said, if it is your particle size is less, volume may be more, and then the size of ferrous material desired to be removed. Then if we know these things, then you can decide that what should be the power of the driving motor, what should be the size of the drum, and then what will be the weight of the whole things, whether you will be suspending it over there or you will be having a separate structure. Those things will be decided. Basically, you will have to know the basic principles and then those components, how they are to be designed for your particular system. That is important. Now, there are different type of your drum magnets are there. There are different companies. You can see the websites of the manufacturer to find out over here. That drum magnet may be your enclosed type of drum magnet. There are structural drum separators and then there are standalone drum separator and weight drum separators. Out of this is your enclosed drum separators, that is your enclosed magnetic drum. They are for the vertical gravity fit suit applications in dry free flowing material, they use it. And then structural drum separators, they are exactly used as a tramp metal removal. If your conveyor belt is going over there, then you can keep a drum that is your magnetic plates with fixed structures, you can keep it over there as a suspended and it will be working. That is a structurally drum separators. Then standalone magnetic drum separators can be very high intensity rare earth and ceramic magnetic cores. This is that rare earth magnets which are manufactured as a permanent magnet. You can see that this is your another very important thing, that is that type of magnet, they do not lose their magnetic property and then they can give a long life, and so once you install, they are all the time they will be working. But when you use that type of permanent magnet, then the whole system, how will you separate it out, either by scraping or by things will have to be done. If you use a electromagnetic magnet, that is your temporary magnet, electromagnet, then what happens, it is a matter of just if you put it outside the conveyor belt, switch off, that is electromagnetism gun, material get dropped. So, there differences are there, but those type of units can be as a structural unit or it can be as a standalone unit. But the most interesting for the mineral engineering, the mining industry, you will have this weight drum separators. There is a different methods also, that is your high intensity magnetic separator WHIMS. Weight separators are used in iron ore beneficiations, in our country also it is used. Then advantages of this drum magnets, when they use it, they can be used as a self cleaning, available in different sizes, accommodate very high volume and easy to operate, and that is electromagnetic things over there. So, now coming, you have already you know about it, earlier also we introduced these magnetic separators, what exactly they are. In the drawing you can see this, that is you are having the magnetic separator over here, and then you can see in an inclined way you keep it, and then the whole material when it is coming over here before discharge, they get attracted to this magnet and then they have got a deflection chute. Through this chute, this material is taken and you can collect to the conveyor or a hopper or a bin, wherever you want to take this material can be taken it out. So, this may be your ore coming over here, these are the tramp metal, maybe these are not required for you, there those may be iron this plate, some small nut, bolts, wires, this may get attracted over, you take it out, now you are getting a better cleaner things to feed into the crushing plant. Now, this sometimes instead of incline it can be a horizontal, that means across the conveyor belt you are putting it over there. So, this material is taken out. It is just only your convenience, space, location and the design, which is again a science and art, that in which way you consider that how will be the interior, how it will look like, how aesthetic the place will be there, that designer will have to look into those things in the bulk material handling. Now, the rare earth ceramic magnets, as I was telling it, that is they are very optimum for large scale processing, they are used, and that you may know that ceramic magnets are also called, that is your ferric magnet or hard ceramic magnet. They are made from strontium or barium ferrite, that is and there are two types of rare earth magnets. One is samarium cobalt and the another is your niobium iron boron cobalt. That that samarium cobalt and this neodymium iron boron, these are rare earth mineral, and because of that they are manufactured, sometimes we say it as a synthetic magnet also, but they are very useful for their you can keep their property, you can control by while manufacturing, you can design it and then you can keep it, they will not get damaged easily and they can give a long life. That is what is the permanent magnets. Now, in a permanent magnet, separators can be used to extract this tramp metal from consumer product or to protect valuable equipment from damage during processing. Now, there are different benefit is there, because that if you are using a permanent magnet, you do not need do not use the electricity for operation. So, that means there could be energy saving, and then this electromagnetic one, there because of the convenience, as I already said you, the convenience and their utilizations, it is also good, and then it can be the whole thing is under your control. If it is damaged also, you can remove certain part, change it and then again reinstall, you can do it. So, these are the pros and cons are of all, you should study a little bit to find out what are they. Then there are many types of magnetic separators that can be, these many types means how they have designed for a particular situation to do. Basic principle is same, basic things are there. Now, it is how you are engineering it. They are used as a cross belt, they are using as a magnetic plate, there is a suspended plate, they can be having a vibratory conveyor magnetic separator, you can keep a vibrating also, you can do it depending on the situation. Sometimes in that container you are keeping, then making the material to flow through that, giving a vibration, so that the particle which are going there, if there is something inside that is not coming within the magnetic range, that can be also attracted, that arrangements can be done depending on the situation. Here there are a lot of such type of photographs and figures you can see in the net, that is where a conveyor belt is going, on that there could be some magnetic particles coming over there. Across the belt we are suspending one permanent the one electromagnet, then what is there in that electromagnetic, this plate which is rotating over here, any scrap material is going on this, they get attracted and this belt they will be driven, and then the magnetic particle will be discharged by the side, and that is here how a magnetic head pulley is given, as I was telling, in a conveyor belt for separating the particles away. Now, this weight high intensity magnetic separation, that WIMS or that high magnetic that high gradient magnetic separation called HGMS, these two are the techniques which are as an advanced technique, they have been used in many your sulfide or beneficiation. Now, you can see here that is the intensity of about 10,000 Gauss of, that is your magnetic intensity you will have to create, that is your that on Gauss is 10 to the power minus 4 Tesla. That much intensity if you had to get over there, then you will have to get a system design and then placed in a way very carefully, and that is why that you can have number of different separators in the line putting over there and they do it. Now, there is also as the wet means what? Exactly the in a slurry form the feed is coming over here, and then they are just getting attracted to those magnetic particles, will be getting attracted to the drum, and they will be discharged over here. And the other one, that is which is non-magnetic, will be coming as a again in the slurry form, it will go out. So, that is where you will be having the launder where their concentrate will be going, and then this your the discharge, that two slurry discharges separating it out where the concentrates are there, where this non-concentrates. So, your the WIMS separators are suitable for applications requiring higher magnetic field gradients, that is your and also it can to remove weak magnetic particles. Even if you use this, that the other systems which we discussed earlier, they may not be able to take out if the particle have got a very weak magnetic properties, but by WIMS even very weaker substance normally we may not get attracted to the magnet easily, because they are having a very feeble that is your magnetic attractions, they can also be done by here. That is what exactly the use of this. So, how that schematically if you see that in a WIMS or in any this magnetic separations, your feed is coming over here, and there is a your in this coil you are generating a magnetic flux over here. When it is going, the magnetic particles which has got strong magnetic property, they will be getting attracted to this, and through this chute they will be coming out, they have got the first magnetic product. Now, then the material will be going through another, that is where you can use a very exact to 20,000 Gauss, like that type of magnetic intensity can be generated over here, and under that high magnetic intensity, this will when it will flow, they will get again attracted by these magnets, and then they will be discharged over there, and then whatever the non-magnetic particles, they will be going on flowing over there, and that is. So, in this wedge system, that by the magnetic they get separated out. So, these are the things you need to know about it.